Hello students, here is Divya Singh, Assistant Professor, School of Computer Application, PBD University. So now we see in this lecture that is cryptography. Cryptography is the process through which the messages are altered so that their meaning is hidden from adversary who might intercept them. Plain text is a message readable by anyone. Ciphertext is the plain text that has been modified to protect its secrecy. So now we see here is a diagram showing encryption and decryption. Here is a plain text which is attached with a key which is converted to a ciphertext that is unreadable text, and there here is this decryption. Here is a ciphertext with an unreadable key, and this is converted using decryption with the secret key to the plain text that is readable text. Plain text is a message readable by anyone. Ciphertext is a plain text that has been modified to protect its secrecy. Encryption converts plain text to ciphertext, and decryption converts ciphertext to plain text. Next, now see, cryptography is used to achieve the following, that is confidentiality, integrity, authentication, non-repudiations. Now see, what is confidentiality? Confidentiality: only authorized persons can access information. Next is integrity. Integrity, integrity means that information that was sent is what was received. Next, authentication, guarantee of originator of electronic transmission. Next, non-repudiations. Non-repudiation is the originator of information cannot deny the content or transmissions. Next, now see, the cryptographic systems can be classified along three independent dimensions, that are the methodology employed in transforming the plain text to ciphertext. Next, the number of keys employed by the algorithm, and next, the manner in which the original plain text is processed. Now see, what is the first one. The methodology employed in transforming the plain text to ciphertext, that is encryption algorithms, are based on two general principles, that are substitution and transposition. Substitution is that individual element in plain text are mapped into another element or a group of elements by employing a chart or fixed pattern in order to disguise them. The order of plain text symbol is preserved. Now see, what is transposition. Transposition, the individual element of the plain text are rearranged but not disguised. The number of keys, next, the second point is the number of keys employed by the algorithm. In this, the symmetric keys and asymmetric keys are used. The symmetric keys, shared or conventional encryption. The same key is shared by both the sender and the receiver. That is, the same key is used for encryption and for decryption. And in next, that is asymmetric. Two keys that are public. One key is public. One key is two keys or public key encryption. That is, sender uses one keys for encryption and the receiver uses another complementary key for decryption. Next, last, the third point, that is the manner in which the original plain text is proposed. So, what is the original plain text? That is stream cipher, and next is block cipher. The stream cipher, the individual element of the stream of data are processed continuously and the output is generated accordingly. Next, block cipher. Block cipher is the input being processed is a block of elements and the output generated is a block corresponding to each input block. Next. Now see what are the types of cryptography. The types of cryptography are private key cryptography and next is public key cryptography. Now we see that is what is private key cryptography. In this, plain text is encrypted with the algorithm and attached with a ciphertext or converted with a key to the ciphertext with a private key, and then this ciphertext is sent to decrypt at the receiver end. Now see the receiver end. The receiver end receives the ciphertext and decrypts with the private key and receive the plain text. Now see what is the private key cryptography. In private key cryptography, the sender and receiver agree beforehand on the secret private key. The plain text is somewhat combined with the key to create the ciphertext. An adversary could not determine the meaning of the message without decrypting the message for which he needs the key. Now, private key methods are efficient and difficult to break. However, one major drawback is that the key must be exchanged between the sender and the recipient beforehand, raising the issue of how to protect the secrecy of the key. Now we see that is what is conventional encryption model. In this conventional encryption model, the plain text with the encryption algorithm is converted into ciphertext, and then the decryption, and with the decryption algorithm the ciphertext is converted to the plain text. Now see the public key cryptography. What is public key cryptography? In this public key cryptography, private key cryptography, the plain text is encrypted with an algorithm to the ciphertext, and then in the decryption algorithm the ciphertext is then converted to plain text. Now see what is private key cryptography. Now, in public key cryptography, two separate keys are used to encrypt and decrypt data. The public key is shared with the other person, and the private key is known only to the person who decrypts the data. So, the private key will remain the secret, while the public key will known to both the parties. Next, the public key cryptography depends on the notion of one wave function. A one wave function is a function that is easy to apply but extremely difficult to invert. Now, we see the conventional encryption model. In this conventional encryption model, when a plain text is converted to ciphertext with the encryption algorithm, and with the decryption algorithm, the ciphertext is converted to the plain text in the conventional encryption model. In the conventional encryption model depicted in the figure, the original intelligible message is converted into a coded message, that is ciphertext. The encryption process consists of an algorithm and a key. A key is a value which is independent of the plain text that controls the algorithm, the output of the algorithm to depend on the specific key being employed at the time of deciphering. Now, the ciphertext generated is transmitted over the network at the receiving end. The ciphertext can be transformed back to the original plain text by using a description algorithm and the same key that was used for encryption. Now, see the mathematically, this model can be explained as follows. The in this we see that the plain text P is encrypted by algorithm E, and the key K is K to ciphertext C. The key K is kept secret, that is C equals to E equals to P, that C equals to EP. Now, next is the description algorithm is used to translate the ciphertext to plain text using the same key K, that is P equals to DC. E and D are mathematical functions or algorithms that encrypt and decrypt for the given key K. Next, since the same last point, since the same key is being used to encrypt and decrypt original messages, it implies that P equals to dk bracket ekp, that is plain text. Now, the security of the above method of encryption is depend on how powerful is the algorithm used for encryption and decryption. More importantly, the security of encryption is depend on the secrecy of the key and not on the secrecy of the algorithm. Now, see some of the problems associated with the use of these algorithms. The problems are: a large or dynamic group of users cannot use them because every time a user leaves a group, All other have to switch to different key to maintain security. If the secret key is accidentally revealed by someone in the group, the rest of the members must change their key. There is no scope for quality control or standardization. Every group of users must have their own unique algorithm and keys. Such a group cannot buy any of these self hardware or software product which are also equally accessible to any web droppers. It does not guarantee effective security. The users themselves have to have a good knowledge of cryptography to write their own secure algorithm and key exchange mechanism. Next, public key crypto systems. See, in public key crypto systems, in this, user A is here and a user B, to which a user A want to send the data to user B. So user A will do with the plain text with the encryption algorithm and convert it to the ciphertext, and at the same time the public key is shared with the user B. Now, next the with the ciphertext, now the encryption algorithm will convert the plain text to ciphertext, and the ciphertext then decrypt by the user B with the decryption algorithm, which with the key which is sent by the user A. In the public key, crypto systems are also called asymmetric two key algorithm because two key sorry two different keys are used for encryption and decryption of the messages. It is computationally infeasible to determine the decryption key given only the knowledge of the cryptographic algorithm and the encryption key. In short, for each public key, there is a corresponding private key, and the two key together form a unique pair. Each end system in the network has a pair of keys to be used for encryption and decryption of messages that it is going to receive. Each system publishes its encryption key, known as public key, by placing it in a public register or file where it is accessible to all. The companion key to be used for decryption is known as private key and is kept a secret. Now see the steps in communication sequence are as follows. A wants to send a plain text P to B, and B has a related pair of keys. A public key EB, which is available publicly, and a private key DB, known only to B. Encrypts P with EB to generate ciphertext C equals to EEB, that is converted by the plain text, and send the result to B. Now, second point, the B is receiving this message and decrypt it with this private key DB to retrieve the plain text, that is P equals to EDB bracket with ciphertext. Now, last, since the original message P is retrieved from the ciphertext by the encryption operation, it follows that P equals to EDB, that is EB, that is plain text. Now see what is comparison of conventional encryption and public key encryption. Now see first the conventional encryption and public key encryption. First is, in order to work it needs, that is the some algorithm with the same key to be used for both encryption and decryption, and the sender and the receiver sharing the algorithm and the key. And in the public key encryption, one algorithm is to be used for encryption and decryption with a pair of keys only for encryption and other for decryption. The sender and the receiver each to be in the possession of one of the matched pair of keys. In order to ensure security, In this, in the conventional method, we see the key must be kept secret, and in the encryption model, one of the two key must be kept secret. Next, the ciphertext, decipher a message if no other information is available should be impossible. Next, to decipher a message if no other information is available should be impossible or at least impractical. Algorithm known and the samples of the ciphertext must not compromise on the key. Algorithm known how, along with one of the keys and samples of the ciphertext, must not lead to the determination of the other key. Next, what are the problems in traditional encryption and encryption problems? The key distribution is a problem. The secrecy of the entire algorithm hinges on the key remaining a secret. For encryption system all over the world, secure distribution amount to impossible tasks. Often, couriers hand carries keys to their destinations. Now, in encryption methods, public key crypto systems are slow and symmetric algorithms have been observed to perform times faster than public key systems. Enough through computer hardware is increasing in speed every year. The bandwidth required to increase proportionally, so there is always going to be a need to encrypt data faster. Next, unmanageable key space. If the use of the key separate key for each pair of users in the network is assumed, then the total number of key is proportional to n square, which is very large when n gets larger. They have been shown to be vulnerable to chosen plain text attack if C equals to EP. When P is one plain text, then a cryptanalyst only has to encrypt all n possible plain text and compare the result to C. This way, one cannot get the decryption key but surely can get P. Now see what are the three types of cryptographic techniques used in general. First is symmetric key cryptography, next hash functions, and next is public key cryptography. Now see first, that is Symmetric key cryptography. In symmetric key cryptography, both the sender and the receiver share a single key. The sender uses this key to encrypt plain text and send the ciphertext to the receiver. On the other side of the receiver applies the same key to decrypt the message and recover the plain text DES algorithms. Next is public key cryptography. This is the most revolutionary concept in the last 300 to 400 years. In public key cryptography, two related keys are used. Public key may be freely distributed while its paired private key remains a secret. The public key is used for encryption and the decryption private key is used RSA algorithm. Next, hash functions. Last is hash functions. No key is used in this algorithm. A fixed length hash value is computed as per the plain text that makes it impossible for the content of the plain text to be recovered. Hash functions are also used by many operating systems to encrypt password. Now see what is public key cryptography. In public key cryptography, which is unlike symmetric key cryptography, we do not find historical use of public key cryptography. It is a relatively new concept. Symmetric cryptography was well suited for organizations such as government, military, and big financial corporations where were involved in the classified communication. With the spread of more unsecure computer network in the last few decades, a genuine need was felt to use cryptography at large scale. The symmetric key was found to be non practical due to challenges it faced for key management. This gave rise to the public key crypto systems. Now, the process of encryption and decryption is depicted in the following illustrations. Here, the sender sends the plain text, which is encrypted by the encryption algorithm and which is converted to the ciphertext, and this ciphertext with the public key, and this ciphertext is decrypted by the private key and converted to plain text and received by the recipients. Now, the most important properties of the public key encryption schemes are: the different keys are used for encryption and decryption. This is property which set this scheme different than symmetric encryption scheme. Each receiver process a unique decryption key, generally referred to as is private key. Receive, Receiver needs to publish an encryption key referred to as his public key. Some assurance of the authenticity of public key is needed in this scheme to avoid spoofing by adversary as a receiver. Generally, this type of crypto systems involves trusted third party which certifies that a particular public key belongs to as a specific person or entity only. Encryption algorithm is complex enough to prohibit attackers from deducing the plain text from the ciphertext and encrypt it with the public key. Next, though private and public key are related mathematically, it is not to be feasible to calculate the private key from the public key. In fact, intelligent part of any public key crypto system is designed a relationship between two keys. Now see the generations of RSA pair. Now see the generate the gen, to gener- how to generate the RSA module N, that is that is each person or a party who desires to participate in communication using encryption needs to generate a pair of keys, namely public key and the private key. The process followed in the generation of keys is described below. Now generate the RSA module N, that is select two large prime P and Q and calculate N equals to P into Q. For strong unbreakable encryption, let N be the larger number and typically the number of 512 bits. Now find the derived number, that is number E must be generated than 1 and less than P minus 1, P minus 1 and Q into Q minus 1. There must be no common factor for E and P minus 1 into Q minus 1 except for 1. In other words, two numbers E and P minus 1 into Q minus 1 are co-prime. Form a public key, a pair of number n comma e the form the RSA public key and is made public. The interestingly, though n is the part of public key, difficulty in factorizing a large prime number ensures that attackers cannot find in in finite time the two prime P and Q used to obtain N. This is the strength of RSA. Next, how to generate the private key? Now, private key D is calculated from P, Q, and E for given N and E. There is a unique number D. The number D is the inverse of E module P into P minus 1 into Q minus 1. This means that D is the number less than P minus 1 into q minus 1 such that when multiplied by e is equal to 1 modulo into minus 1 into q minus 1. This relationship is written mathematically as follows: minus ed equals to 1 modulo p minus 1 into q minus 1. The extended Euclidean algorithm takes p, q, and e as the input and gives d as output. Now see what some example. This example shows how RSA key pair works. An example of generating RSA key pair is given below. For ease of understanding, the prime P and Q taken here are small values. Practically, these values are very high. Let two prime numbers be P equals to 7 and Q equals to 13. Thus, modulus N equals to P into Q equals to 17 into 13 equals to 91. Select E equals to 5, which is valid choice since there is no number that is common factor of 5, and minus 1 into Q minus 1 equals to 6 into 7, 12, that is 72, except for 1. Now the pair of numbers n comma equals to 91 comma 5 forms the public key and can be made available to anyone whom we wish to be available to send us encrypted messages. Input P equals to 7 and Q equals to 13 and E equals to 5. To extend eliciting algorithm, the output will be D equals to 29. Check that the D calculated is correctly by computing the E equals to 29 into 5, that is 145 equals to 1 modulo 72. Hence public key is 91 comma 5 and private key is 91 comma 29. Now see what is encryption and decryption. Once the key pair has been generated, the process of encryption and decryption are relatively straightforward and computationally easy. Interestingly, RSA does not directly operate on strings of bits as in case of symmetric key encryption. It operates on the number of modulo n. Hence, it is necessary to represent the plain text as a series of number less than n. Now see RSA encryption. In RSA encryption, suppose the sender wish to send some text message to someone whose public key is n, e, and the sender then represents the plain text as a series of numbers less than n. To encrypt the first plain text P, which is the number of modulo n, the encryption process is simple mathematical steps as C equals to P की power e mod n. In other words, the ciphertext C is equal to the plain text P multiplied by itself E times and then reduced modulo n. This means that C is also a number less than n. Returning to our key generation examples with the plain text P equals to 10, we get ciphertext C equals to 10 की power 5 mod 91. Next, RSA decryption. Now, RSA decryption, in this, the decryption process for RSA is also very straightforward. Suppose that the receiver of public key pair n, e has received the ciphertext C. The receiver raised C to the power of private key D. The result modulo n will be plain text P. That is plain text equals to C की power D mod n. Next, returning again to our numerical example, the ciphertext C equals to 82 would get decrypted to the number 10 using private key 29. That is plain text equals to 82 power 29 mod 91, that is 10. Now, RSA analysis, the security of RSA depends on the strength of two separate functions. That is, RSA crypto system is most popular public key crypto systems, the strength of which is based on the particular difficulty of factoring the very large numbers, that is encryption function and key generation. In this, if either of these two functions are proved non-one way, then the RSA will be broken. In fact, if the technique for factoring efficiently is developed, then RSA will no longer be safe. The strength of RSA encryption drastically goes down against attacks if the number P and Q are not large, primed, and or choose public key E is a small number. Now, thank you for listening me.